numericals which we have done earlier? Okay. So no doubt with the numericals? Anyone? Okay. So we will proceed. Just want to make clear with you that the first law has failed to to comment on if this reaction will take place or not, and therefore this entropy come into play, and it has also could not commented fully on the reaction will take place or not. So finally we will get Gibbs free energy, like for example this, for example H2 plus O2 gives H2O, right? Gas. So here this entropy, this enthalpy is minus. This is for only for example, so that you can understand it well. So the enthalpy is delta H is negative. So this is an exothermic reaction. Okay. So this is well and good. This happens. This hydrogen and oxygen reacts, and this gives. However, if, for example, ice is converting into water, ice is converting into water. So delta H here will be what? Positive. So ice is taking energy. It is taking energy in itself. So it is absorbing energy to convert into water, right? Are you getting me? Delta H is positive here, everyone. Alina, Ali, Jobita, Jesslyn, Sabia, Shaima. Delta H is positive since this ice is extracting energy. So the delta H is positive here. Are you getting this?
Yes, sir.
Yes, sir.
So this is endothermic. So both the both the process are spontaneous, right? They happens. The hydrogen mixing hydrogen with oxygen with a little spark, they will convert into this H2O in gaseous form. And ice can also convert into water. Delta H here is negative, delta H here is positive. Both are spontaneous. So we cannot confirm that reaction will happen or not, process will happen or not with respect to delta H. Okay. So we will not confirm that delta H with the respect of delta H that reaction will be spontaneous or not, right? बच्चों,
Yes, sir.
Yes, sir.
endothermic and exothermic reactions. Exothermic reaction or process can be spontaneous or non-spontaneous, right? Can be spontaneous or non-spontaneous. Are you getting this point?
Yes.
So then we have understood the term of entropy. Like ice is this same example. Ice is converting into water. Ice is converting into water. So can you comment on it? Delta S is positive air or negative air? Ice converting into water. Ali, the entropy has been increased or decreased when ice converts into water.
Positive.
Jesslyn,
Sir, it increases.
huh? What you have said, Ali?
Sir, the entropy increases.
Entropy increases. Jesselyn, what do you think?
It increases.
Yeah. So don't have doubt in this. This is very simple thing that ice is a solid thing. Solid has converted into liquid. So the entropy has been increased. The randomness has been increased. Okay. So this is an example of delta S is increasing. Okay. However, let's see another example. When water vapor is converting into liquid, okay, or water. So can you say, Alina, what delta S is positive air or negative air? Can you comment on it? Delta S is positive or negative? Change in entropy. Entropy of substance has increased or decreased?
Increased.
Okay. Sabia, what do you think? Entropy has been increased or decreased? Sabia, are you there? Okay, Jesselyn has answered. Okay. Shaima,
Yes, sir.
what entropy has increased or decreased?
Decreased.
Yeah, decreased. This is very simple. You have to remember this. Means there should be no doubt in this. Thus, water vapor, the water vapor has the tendency to go here and there. It is in the form of gas. The randomness is very high here, and in the liquid, water vapor is here. In liquid, the particles have been converted into liquid phase. So this has got less intermolecular distance, more intermolecular force. So they have lesser randomness. So from this, you can say that in this both the processes, what happened? These both processes are spontaneous, right? Are they not spontaneous? In terms of in the in the world, can you see these are spontaneous? This second one is not spontaneous. However, it is happening, right? We have already told that entropy increment, when the entropy increases, then only is a spontaneous process, right? So this is not happening. by itself. Spontaneous processes that it happens by itself. If it happens by itself, then it is an spontaneous process. Like ice is converting into water. This happens in our daily life. It happens in nature. Okay. Now, let's see a unique example. Let's see what is happening. Let's make a table first. Delta S of system. Before this, let's take an example at -1 degree Celsius. Okay, we have taken water. Okay, what will happen at -1 degree Celsius? What happened with water? It will convert into, water will convert into Ali. At -degree Celsius, water will convert into Ali.
Yes, sir.
At -1 degree Celsius, water will convert into water vapor.
Ice.
Ice. Water has converted into ice. So, according to our knowledge, delta S of system has been decreased, right? It is negative. You can say it is negative. However, at -1 degree Celsius, this process happens, right? Is it not spontaneous as -1 degree Celsius? If you put in any environment at -1 degree temperature, water will convert itself by itself, or it is done by by some force, external force. Sabia, what do you think? At -1 degree Celsius, water will convert directly into ice, or we have to do some work on it? Alina,
Yes, sir.
what do you think? At -1 degree Celsius, we have to do extra work to convert a water into ice, or it will spontaneously freezes to ice?
Spontaneous.
Yeah, so at -1 degree Celsius, we don't have to do external work on it. At -1 degree Celsius, it will directly convert into ice. Okay. So what is, however, we can see delta S of system is negative. We have understood that liquid is converting into ice. This is negative. So what is happening? What is happening is we have to check this to happen this process. To happen this process, delta S total should be negative. This is 100% true. This should be true. To process this reaction, delta S total should be negative. So what is happening is delta S total is actually delta S of system plus delta S of surrounding. Delta S of surrounding. Okay. So what happens? Here delta S is negative. Okay, so here delta is delta S surrounding is very, very high in positive terms. Therefore, delta S becomes positive. Sorry, I've done this thing wrong. It should be positive always. So delta S is positive here overall. That is why this process happens actually at -1 degree Celsius. Got it? Anyone? Any problem?
No, sir.
Let's confirm with some data. So you can observe with your eyes. Delta degree, the temperature is in degree Celsius. Let's check at -1 degree, 0 degree, and 1 degree. Delta S of system here is 2.2. Here it is minus. At a -1 degree Celsius, delta S of system is negative. So we are confirming that, and delta surrounding is 21.9. And at 0 degree Celsius, delta S of system is 21.9. Delta S of surrounding is also 21.9. Delta of system at 1 degree Celsius. At 1 degree Celsius, liquid, this water wants to become ice. No, at 1 degree Celsius, water will not become ice. So delta S of system is here very much negative. So see, when we calculate it, so here at -1 degree Celsius, delta S total is in positive thing. Okay, this is positive. 21.9 here, and here it is -21, -2. Round off. Here delta S is 0, and here delta S is negative. Right? So at -1 degree Celsius, delta S total is positive, means that liquid will convert into ice, because we have to comment on delta S total. We have to deal with this. And here delta S is negative. So this will not happen. Liquid will not convert into ice at 1 degree Celsius. Are you getting this? Delta S total negative is not possible. This will be non-spontaneous. This will not happen. Non-spontaneous. At 1 degree Celsius, water will not convert into ice. Okay? Are you getting this? Everyone?
Yes, sir.
So this is a case in which delta S of system is negative. However, the process is happening. Ice, water is converting into ice because delta S of surrounding is, very much positive. So delta S total will be positive, thus spontaneous. Ali, have you understood this?
Yes, sir.
Jaslin?
Yes, sir.
So you understood the whole concept? Everyone?
Yes.
Yes, sir.
Jobita? I want to also comment on it that at 0 degrees Celsius, you know that this ice and water both phase occurs, right? In previous classes, you may know that ice and water are, in equilibrium, means both are present at 0 degrees Celsius. Are you comfortable with that? Everyone? Yeah, are you not sure that at 0 degree water can be present? What do you think? Shaima,
Yes, sir.
what do you think? At 0 degrees Celsius, only ice is there or only water is there?
Sir, both are there.
Okay, good. So both are present at that temperature. Means this is a clear sign that delta S of that point will be 0. Means at microscopic level, ice is constantly converting into water and water is constantly converting into ice. So both are present at this temperature. That is why delta S here is 0. Got it? Everybody? Everyone? I cannot hear anybody.
Yes, sir.
So we have fully converted, we have fully seen H, delta H and delta S. So then Gibbs energy come into play, that it deals with both type of energy. Delta G comment on both type of energy, H and T delta S. And with delta S also and delta H also. And if delta G is negative, then finally there is 100% confirmation that it will be spontaneous or non-spontaneous. But with delta H, we cannot comment. We cannot comment for sure that the reaction will be spontaneous or not. Okay. But with this delta G, we can 100% comment that yes, reaction will be spontaneous or non-spontaneous. Okay. Got my point? Bachcho,
Yes, sir.
have you understood this point? This whole point which we have discussed in around half an hour. That delta S and delta H will not confirm that the reaction will be spontaneous, that process will happen. Only delta G, which take this both the terms with it, will comment for sure that the reaction will be spontaneous or not. Okay. Got it?
Yes, sir.
Okay. So now we will take different scenarios in which and we will compare that what is happening. Meantime, I want to say that complete your homeworks and we will discuss and raise doubt if you have it, so that you can feel confident about it. So let's proceed. So let's take for example delta H negative, delta H as negative, and delta H negative. Wait. So delta H negative is a favorable condition, right? This is an exothermic reaction. Got my point? Have you copied this? Everyone? I'm sorry, I will
No,
not giving you time to copy. Everyone, have you copied? We will proceed then only. Ali? Do you want to copy anything?
No, sir.
Okay, Alina?
no, sir.
Okay. So what we are saying? So don't you think that exothermic reactions are spontaneous? Means we can say spontaneous because it is releasing energy, right? So this is a favorable condition because it does not want energy. Means it does not want anything from us. They are releasing energy. So this is favorable condition, right? Favorable condition for spontaneity, I was saying. And delta S is positive. Let's assume delta S is positive. So this is also a favorable condition for spontaneity. Right, everybody? Delta S positive is one of the sign for spontaneous reaction. Means it is a favorable condition, right? Okay, sorry, Jesslyn. Shaima,
Yes, sir.
delta S positive and delta H enthalpy is negative. So both are favorable condition for spontaneity. Because delta H negative means we don't have to give external energy, and delta S positive means randomness is increasing. So both are favorable, right? What do you think, Ali? Ali,
Yes, sir.
don't you think both are favorable condition for spontaneity? Only one or two people are sending me messages, the right answers. Rest are keeping quiet or neither messaging nor saying anything. Okay, got it. So let's see here. So delta H is negative. In this case, delta H is negative and delta S is positive. So this is negative and whole thing is positive. Temperature will be always be positive in chemistry. Temperature is always positive because you see temperature is -5 degrees Celsius also, right? But in chemistry and physics, we only talk in Kelvin. Okay, so in Kelvin, temperature is always positive. Below 0 Kelvin, we don't talk about it, and we don't do experiment. This is very low temperature, -273 degrees Celsius. So delta T is always positive. So this will be whole thing will be negative only, and this is negative only. So finally, delta G will be negative, right? Everybody, I want to get response from everybody. Either message or tell something. Jobita,
Yes, sir.
So delta G is negative here. Can you see from the, this equation?
Right.
Sabiha? Sabiha? Okay, let's proceed. So delta G is negative means this is a spontaneous one, right? So we have achieved what we want. So this is spontaneous. So both conditions are favorable. So there was a high probability that it will be spontaneous, and this is exothermic also, right? Let's move to the second case where this delta H will be positive, means this will be a endothermic. This is a non-favorable condition, and take this delta S as negative. Delta S as negative. So this is also a non-favorable condition. So let's put this in this, in this equation, and let's check what will happen. So delta S is negative here. So negative, this will be a big positive thing. And delta H is also positive. So delta G is also coming positive. Delta DG is also coming positive. So this is a non-spontaneous reaction, right? Are we good? Jesselyn, you can message. Tell me if I have to repeat. Okay, got some messages. Ali, what do you think? Is this reaction spontaneous or not? Ali? Non-spontaneous. Okay. Okay. So let's take some another examples. Let's take delta H as negative, okay, and delta S also negative. So what will happen? Delta S is negative here, okay. So this is a favorable. Delta S is negative here. So this one will be positive, and this one is negative. So there is some, clash. Delta H is negative here, and this whole thing will become positive, right? So what is happening? We have to reduce this delta positive thing. If we will reduce this positive thing, then it will be well and good, because the negative will dominate. Then the process will become spontaneous. So at low temperature, when we reduce this thing, positive thing, then it will be good for us. The delta H will become more, more negative. So delta G will be negative. So for example, you can see here, like delta G should be delta H is negative. No. Temperature should decrease so that this the whole positive thing will decrease. Okay. So at low temperature, reaction can be spontaneous, right? Spontaneous. At low temperature, reaction can be spontaneous, right? When delta H is greater than T delta S. So you can also say delta H upon, don't have to remember it. I'm just, showing you full. The temperature should be lesser than this. Temperature should be lesser than this, so that you will get negative delta G. So that you will get negative delta G. Got my point? This is conditional. It depends on temperature, right? Got my point? Kindly
Yes.
respond.
Yes, sir.
Let's take the final case where delta H is positive and delta S is positive. Wait. Okay. So now what we will see? You can clearly see that delta S, since delta S is positive, so whole thing will be negative only, and delta H is positive. Okay, so we have to increase this temperature. If we will increase this temperature, this negative thing will increase, and we want this to be negative only. Okay, so it will become negative if at high temperature. At high temperature, reaction can be spontaneous. And you can see delta H should be lesser than T delta S. Delta H should be lesser than T delta S, and thus we can conclude that delta H upon delta S, it should be lesser than temperature. So at high temperature, this can be possible. Got my point? Everybody understood this thing?
Yes, sir.
So you can, you can do this in each and every case.
Yes, sir.
Good. So copy it down first. And just let me know when you are done. So by this, we can conclude that many processes or reaction are highly dependent on temperature. With increasing or decreasing temperature, a process can be spontaneous or non-spontaneous. Like when we decrease temperature too much, water will directly become ice. We don't have to worry about it. And if we increase the temperature, water will not, become ice. So it will become non-spontaneous. So they are dependent on temperature. So this can be concluded after this, understanding. So we have seen that the spontaneity is, however, it is dependent, but not, cannot confirm with it with respect to delta H or delta S, whether reaction will be happening or not happening. Okay. Achha, have you studied this chapter equilibrium?
No, sir.
Okay. Okay. Done with the copying?
Yes, sir.
Everyone?
Yes, sir.
Okay. There is a little a small topic. However, This is actually related with equilibrium chapter, but still this is given in this topic because it is Gibbs energy is dependent on equilibrium actually. So topic is Gibbs free energy. Gibbs free energy and equilibrium. You will get feeling of equilibrium in the equilibrium chapter. However, you have to know the formulas which is involved in this. The formula is mathematical formula. You have to understand it. Delta G is equal to delta G naught plus RT ln Q. Okay, where Q is reaction coefficient. So what is reaction coefficient? See, let's take an example. A mole of A and B mole of B is reacting to give C mole of C and D mole of D. We have to do just numerical of it, but how it is coming, I'm just showing you. Get familiar with the terms. So this is it. This is coming in equilibrium chapter, so you don't have to worry about it. Okay, so this is reaction coefficient. This is the concentration. This term means concentration of A. Okay, do you know this concentration term? Okay, no problem. So see, at equilibrium, what happens? At equilibrium, delta G is 0. Okay. Why delta G is 0? Because delta H is also delta H and delta S is 0. So overall delta G is also 0. And Q becomes K. Okay. So you don't have to understand what is happening here. Just you have to copy it down. We will understand in next chapter the whole detail. However, Gibbs energy, free energy is we have to complete this topic. It is in this chapter only. Okay. So delta G is equal to delta G naught plus RT ln Q. This standard, this symbol means standard Gibbs energy. So delta G is 0 at equilibrium. So this will become 0. This will be there only because standard, and R is universal gas constant. T is the temperature. ln K. Okay. So we will move this side. Minus RT ln K. Okay. Then ln will log 10. We will convert this 2.303 RT ln K. Okay. So delta G, we know delta G naught is delta G is delta H minus T delta S. So delta G naught is delta H minus T delta S. This is standard, means this is done at a a specific temperature of 1 mole of a compound. So what is that is the we have make a standard of it. So delta G naught minus T delta S is equal to finally minus 2.303 RT ln K. That is it. Okay. So this is the final formula. You have to first note it down. We will you don't have to understand much of it. However, there are numericals present in it, so we will try them out. First, write it down. Done? Everyone? Hello.
Yes, sir.
Done.
Yes, sir.
Okay. So wait a minute. Anyone having any doubt? You can ask me. In the theory part, because numericals are too easy, you can do it. Anyone having doubt?
No, sir.
Okay. So this question is from NCERT. We will try it in a minute only. So you don't have to worry about this. So first read out the question that we have to find the equilibrium constant. What is equilibrium constant? This K. Okay. Okay, this is the equilibrium constant. Don't worry, we will deal with them in next chapter. So this we have to find the equilibrium constant. The reaction is given, the temperature is given, 298 Kelvin. The reaction is given, and the standard Gibbs energy means delta G naught is given. Okay, so we have to just use this formula. Delta G naught is equal to minus 2.303 RT ln K. Okay. So delta G naught is given minus 13.6 kilojoule. Means we will do this thing. Okay, is equal to minus 2.303. Okay, we will put the value of R. The R will be 8.314. We'll put the value of T. T temperature is given as 298. Okay, we don't have to change the temperature. It is already given in Kelvin, and we will put this ln K. So we will solve this equation. Okay, we will put this in the denominator, and we will get ln K, and after that we will log K. This is log K. Got it?
Yes, sir.
So log K here will be 2.38. Then what we will do? We will do this 10 to the power 2.38. Got my point? So
Yes.
that is how we will solve this question, and we will get this answer of this question. So I think you don't have problem with the numerical. No problem with the numerical part. I will send you the questions.